Okay guys, let's take a look at today's lesson. So what we're going to be looking at are hyperbolic functions. Hyperbolic functions are really based with exponentials. They are based on exponentials, which is one of the reasons that we're looking at them. They are very close to our trig functions. They're very close to that. So I think it's a really good thing for us to look at. We really don't use hyperbolic functions that much in Cal 1 or Cal 2, but we do use them in Cal 3. So I think it's pretty important for us to at least know what they are, know that they exist, and work with them just a little bit. So let's take a look at basically some properties of them. If you'll look, the properties for our hyperbolic sine, cosine, tangent, cotangent, secant, and cosecant are all exponential based. They are all exponential based. Notice, let me bring that up a little bit. Okay, so they have, e to the x minus e to the negative x over 2. That would be the one for the hyperbolic sine. I put the pronunciations right here, so I know we really haven't said them before, and not that you have to say them, but to pronounce the hyperbolic sine, it's sinh. I know the words sound weird because we're not used to these words. Hyperbolic cosine is cosh, hyperbolic tangent is tanch, cotanch, sech, and cosech. So that's just the way that you pronounce them, just in case that was a curiosity to you, or if you wanted to say them. So some of the properties that we are familiar with are still the same. If you look here, it's like a quotient rule for tanch, is sinh over cosh. Same kind of thing. So some of these properties are exactly the same as our trig properties, and some are different. I don't want you to have to memorize the ones that are different. I would give you those on a table or a chart. Only the ones that would be the same would be the ones that you would be required to know, because you already know those. But I don't want you to memorize something that's opposite of what you are used to. So those I would write, like for our test, I would give you a chart with all that information on it. You do not have to memorize that. You do not have to memorize, for example, this formula right here. That's not required. You don't have to memorize that. I will give you that information. I just want you to be able to know that it exists and be familiar with it and be able to use it. That's all. So that's kind of an overview for these are the definitions. So let's look at some of the other options that other properties that we're looking at. So let's go over here to our regular properties. Bring that back a little bit. All right, so notice that there's a little bit of a different property here. We're not used to this one. And we don't have anything like that in regular trig where sine plus cosine is anything in particular. But this is a true statement. Cosh plus sinh is e to the x. It's kind of unusual. We also, this one right here is different. Right, in regular trig, cosine squared plus sine squared is 1, but look at this as the subtraction. It's cosh squared minus sinh squared is 1. So that's a little different. Again, you don't have to memorize the ones that are different. I'm going to give you those. Other things that are really the same, our even and odd properties are the same. Our addition and subtraction properties, some are the same and some are different. Notice how sinh is the same. That sign would be of the addition, but cosh is not. Look how nice cosh plays. It's a plus and it's a plus. Okay, so that's not. So again, no need to memorize the different ones. We're just going to, I'll give you those. But you do need to reference them and we will use them. And that's so let's look at one other thing before I switch locations. Let's look at the graph just kind of briefly. Just briefly, and this is where the values come from. They're called a hyperbolic function because they come from a hyperbola. That's where they come from. That's why they're called a hyperbolic function. All right, any questions on the overview before we do some examples? All right, let's do some examples. All right, so the first one, says find the exact values using the definitions, and we have Sich of 0. So the first thing that we're going to do is what I would do. I'm going to write down the formula for Sich. It is 2 over e to the x plus e to the negative x. Okay, so that what we're basically going to do is just substitute into that. We're going to take the 0 and we're going to plug it in everywhere there's an x. So I would have 2 over e to the 0 plus e to the negative 0, and we know that 0 can't be negative. So that basically ends up to be 2 over, I don't know what that was, that's as a plus. So 2 over, e to the 0 is 1, and e to the negative 0 is 1, right? So we have 2 over 1 plus 1, or 1. And so Sich of 0 is 1. Now on your graphing calculators, your hyperbolic functions are in there. They're kind of hidden. I don't know, just letting you know that they're in there. You would have to go to the catalog in your calculator to find them. And that, though we're not going to be using it very much, I just want you to know that they're there. They're just not a button on your calculator, but they're in the catalog. If you wanted to double check your work on values, you could certainly do so. Let's look at the second one, a b, that's asking us for tanh of natural log of 2. So let's do that. Okay, so pull that up a little bit. Okay. So let's copy that formula down for tanh. That would be e to the x. So we'll copy the formula down up here. So e to the x minus e to the negative x over, then we have e to the x plus e to the negative x. So that is the definition of tanh. That's the definition. What we're going to do is we're going to put natural log 2 everywhere there's an x. So wherever there's an x, we're going to insert natural log 2. So we'll have e to the natural log of 2 minus e to the negative natural log of 2 all over e to the natural log of 2 plus e to the negative natural log of 2. Okay, we've been working with exponentials for a little while. I'm hoping that we're comfortable with knowing how to simplify that. So e to the natural log of 2 would simply be 2, right? The e to the natural log would cancel out. This one with the negative exponent, we can't really simplify that until we move the negative exponent right up into, so this negative e, right, this negative right here, we need to put up, we need to pull this up into the exponent of the 2. And so I'll just write one more step just so that we're clear what's going on. So we have e to the natural log 2 minus e to the natural log of 2 to the negative 1 all over e to the natural log of 2 plus e to the natural log of 2 to the negative 1. Alright, so we know 2 to the negative 1 is 1/2, right? So I could further simplify this. Let's just go to simplification. E to the natural log of 2 is 2 minus e to the natural log of 2 to the negative 1 is 1/2 all over 2 plus 1/2. Okay, are we okay with that? I'm just simplifying my exponentials. So now let's just compute that, do our arithmetic. So 2 minus 1/2, that gives us 3/2. And then 2 plus 1/2 gives us 5/2. So we fix that complex fraction and we get 3/5. So tanh of natural log of 2 is 3/5. Okay, we okay with that? Alright, let's go on to a different kind of problem. Let's move back up to the top of the page. So we'll talk about, yes, I know you're going to be excited. We have proofs. Yay! But some of the proofs are a little bit different. So let's look at the difference in the way these are written. So this one says verify using definitions. This one says just verify. These are two different techniques that we're going to be using to verify. Okay, one we're going to use definitions, which are those e to the x definitions. The other we're going to do just regular, trig stuff. All right, so let's do that. So using the definitions, we have this that we're going to be working with. This is what we're supposed to verify. So I'm going to write down the definition for cosh. And so that is e to the x plus e to the negative x all over 2. Okay, that's my definition of cosh. So that's what we're going for. We're proving using the definition. So I'm just going to write down the definition here, e to the x plus e to the negative x over 2. Okay, so that's what we're going for. So for this one, what I'm going to do is I'm going to take this cosh negative x and I'm going to plug in a negative x everywhere there's an x. That's what I'm going to do to attempt to verify this. So let's do that. So I have e to the negative x plus e to the negative x all over 2. So I simplify that and I get e to the negative x plus e to the negative x would just be e to the x over 2, and that equals the definition. So that's supposed to be a check mark. So we're done. That was a fairly straightforward one, but that's what you would do if you're going to verify using the definitions, is you would, use the definition, right? You would write that down and you would plug into the definition to make that happen. So let's look at the other kind of verification. Let's look at just a regular old proof. That would be like this one on the right where it says verify. All right, so this one I'm going to choose to work the right-hand side. And so we would say, LHS, left-hand side, equals. And I'm going to just do some properties. Again, properties that are different than the ones we're used to, I would give you on a chart. Sech squared, we can use the reciprocal property on it. It's 1 over cosh squared. So that's what I'm going to do. So we have 1 minus 1 over cosh squared. And that would be reciprocal. Okay, so I have 1 over cosh squared. Sorry for the writing. Hopefully you can, hear my voice and know that's supposed to be cosh squared. So now I'm going to find a common denominator and add those together. I'm going to take that 1 and I'm going to turn it into cosh squared over cosh squared minus 1 over cosh squared. And that would be common denominator. Okay, so now let's combine those together. Let's go ahead and subtract those. So I would have LHS equals, so we have cosh squared minus 1 over cosh squared, and that would be just subtraction. Okay, so there is a property, cosh squared minus 1 is actually sinh squared, but I mean that's unusual, and right, for us we would know 1 minus cosine squared is sine squared. All right, this is the opposite. It's cosh squared minus 1 is sinh squared. So we're going to turn that. So LHS equals sinh squared over cosh squared. And that is, we're going to call it Pythag, just because that's what we used to call it. We're going to call it Pythag. It's not really Pythag, but we're going to call it that. And then the last step, sinh over cosh is tanh. Those words sound weird, don't they? Saying them over and over again, I think they sound weird. At any rate, so we're going to turn that into tanh squared, and that would be the quotient property. And there's our verification, our proof. Okay, we okay with that? All right, there's a couple of more here. I'm going to scoot this down so we can look at these other two. All right. So we're going to work on this one right here. So to rewrite the expression in terms of exponentials and simplify. Okay, so that means we're going to have to use the definition. We need to use the definition for cosh. We had just written that down previously. It's e to the x plus e to the negative x over 2. So let's insert that in. So we're going to have 2 times e to the x, so e to the ln x, plus e to the negative ln x over 2. Okay, so we're just substituting that in. We're doing exactly what it says, rewrite the expression in terms of exponentials and simplify. So we rewrote it in terms of exponentials, that's done. Now let's simplify. Those 2's go away, right? E to the ln x is just x, and e to the negative ln x, okay, we've got to do that thing where we bring this negative up into the argument, right, and make it the exponent. So that's going to be e to the ln x to the negative 1. And so let's work through that. So e to the ln x is x, plus e to the ln x to the negative 1 is x to the negative 1, right, which is 1 over x. That's perfectly acceptable to leave it like that. Let's say that you want to make a common denominator, add them together. That would be fine also. You can certainly do that. If you make a common denominator and add them together, you would get x squared plus 1 over x. Either one of those answers would be acceptable. One is just, 2 separate fractions and one is 1 fraction, but they're still both completely simplified. Okay, is that okay? Now the last one is going to require us to pay attention to the graphs of sinh and cosh and all those. I don't need you to memorize the graphs of them. I would give you them. But what I'm going to do is I'm going to write them on here so that you can write them down, and I'll explain why they're important. So let's get a little bit of room here. Okay, so I'm going to draw the graphs right above here. So the graph for sinh looks like this. Okay. The graph for cosh looks like that. Looks kind of like a parabola. The graph for tanh looks like this, and that goes through the origin. The graph for sinh looks like this. Cosech looks like this, and cotanh looks just like cosech, well, very similar. So why do we need to know these? Well, let's look at what they want us to do. They want us to find the values of the remaining 5 hyperbolic functions. Well, the remaining 5 hyperbolic functions we can't find like we did with regular trig functions. We can't use the triangle and calculate them that way. That's not the way that we have to do this. There's really one way to do this, and we're going to have to use a particular identity. We're going to have to use cosh squared minus sinh squared equals 1. So let's write that down. So cosh squared minus sinh squared equals 1. So you're really only going to be given either a value of sinh or cosh. That's it. You have to start off with a value of sinh or cosh, and then you have to find the other 5. All right, so no other option. That's what you have to start out with. So we're going to start out, we have a sinh, and it's negative, which means that it's on this side. right? It's left of the y-axis. This is where the negative cinch would be. But when I find cocinch, that's just going to be, or cosh, that's just going to be this right here. It's always positive. So we needed to know that. We need to know if it's always positive when we find our cosine value, our cosh value. So let's use this formula. So we would have cosh squared x minus, and cinch is negative 3/4 squared equals 1. Okay, so we're going to plug into that formula. Now we're going to solve for cosh squared. So I have 3/4 squared, negative 3/4 squared would be 9/16. So I have cosh squared, and then equals 1 plus, I'm going to go ahead and move this over, 1 plus 9/16. So cosh squared is what, 25/16? Then I square root both sides, and I get that cosh is plus or minus 5/4. Now I know it's not a negative 5/4, right? It's not a negative 5/4 because it's never negative. That's why I need the graph, just to verify that I have the right sign, that's all. It's never negative. So, alright, so now I know, let's kind of write our values here. So cosh is going to be 5/4. Okay, so that's 1. Then we have the reciprocal of cosh, which would be sech, right? We're just going to flip that upside down. So that would be 4/5. Sorry, that's a horrible looking 4/5. I hope that you're listening. That's 4/5. What about cinch? The reciprocal of it would be what? Cosech. So let's write it down. So C, where are we? There we go. SCH is going to be negative 4/3. Then what do we have left? We have tanh. So tanh is cinch over cosh, right? So I need to do negative 3/4 over 5/4. Right, negative 3/4 over 5/4. And so tanh, we fix that, flip that and fix that, and we get negative 3/5. And that leaves one more, and that would be cotanh, and we're just going to do the reciprocal. We're just going to flip it upside down. So cotanh is negative, where are we? Negative 5/3. All right. How are we doing? Do we have any questions?